Hello everyone, I'm Varshita. Today's subject is analysis and design of algorithms. Today's topic is sorting method using brute force approaches. In this video, we are going to learn about brute force and its real world examples and algorithmic approaches. Now let's see what's a brute force. A brute force is a straightforward method used in algorithmic program solving or a problem solving that checks every possible solution until the correct solution is found. For example, we can take the real world example we can take as password cracking, encrypted file decryption, ATM pin hacking, and combination locks. Combination locks such as digital padlock or manual padlocks, they can be manually done or using automatic software. For instance, if a person's password is a combination of letters or numbers or any symbols, a brute force attack would involve systematically trying every possible combination until the correct password is discovered. This brute force method is time consuming but can also be effective if the password is weak or short. In example, we can take a padlock. If you have a three digit padlock, it has a possible outcomes as 1,000 possible outcomes. A brute force attack on this padlock would involve trying each combination sequentially, starting from 0 to 000 and then 001 or 002 and so on. In this example, we can see the outcome is 614. So we have to try from 0000 to 614 until the lock opens. At last attempt, we get the lock opens. While knowing about the brute force algorithm, the examples there are many examples like searching for an element in a list or an array, sorting a list or an array, calculating the factorial of a number, and calculating the nth term of the Fibonacci sequence. Finally, we can say that brute force algorithm function by searching each element sequentially until the desired result is found or all the options are exhausted. Now let's see what are sorting methods in brute force approaches. So sorting is the process of arranging items in a particular order, typically in ascending or descending order. In brute force approaches, there are typically three types of sorting algorithms, that is selection sort, bubble sort, and insertion sort. These algorithms are considered brute force because they rely on the straightforward comparison and swaps without any advanced techniques to optimize the sorting process. While they are simple and implement, they are not most efficient for large data sets compared to more sophisticated algorithms like mudsort or quicksort. See what is selection sorting. Selection sort is a simple sorting algorithm that repeatedly selects the minimum or the maximum element from the unsorted portion of the list and swaps it to the leftmost unsorted element. So this is the algorithm for selection sorting. Here we take high as the current position, and this current position will be taken up to n minus 2, and we will take I as the minimum element. And in this for loop for I, we will take the another for loop for j, because if we have any element which is lesser than the minimum element, we will take jth position as the minimum element, because which will be the lesser value than the actual I element. So let's see with the example in an animation way. Here we are taking up to 7 elements. We will first check which is the minimum element and place it as I, and then we will check for all the elements, then swap, and again we will check the second element or the minimum element. We will place it as I, then swap. This procedure will continue up to we will get the correct order or the ascending order. So now we got that the ascending order, that is 0, 2, 4, 5, 6 and 6, 7 and 9. This is the ascending order selection sorting example. Selection sort as a time complexity of an order of n power 2, where n is the number of elements in the list. That means its performance degrades quadratically as the size of the uh, input increases. Well, it's not the most efficient sorting algorithm, especially for large data sets. It is easy to implement and work well. It works well for small lists or as a teaching tool to understand the sorting algorithms. Now let's see about bubble sorting. Bubble sorting is a simple sorting algorithm that repeatedly steps through the list, compares the adjacent elements, and swap them if they are in the wrong order. So this is the algorithm for bubble sort. That is, we take the ith position as 0 to n minus 2. If this function is true, well, it will do for again the another for loop, that is for j, that is up to 0 to n minus 2 minus I. If this for loop was also true, it will do if a of j plus 1 will be taken as a of j, and swap the j element to the j plus 1 element. So now let's see the example using an animation video. So here we are taking 3, 2, 1, 6, 4, 5 an example. It will check as the current passes like 1, 2, 3, 4 and 5. The first current pass is completed, and now it is taking a second current pass, and this is the third current pass. It will check up to we get the correct order. So now this is the correct order. Bubble sort has a time complexity of order of n power 2, where n is a number of element in the list, and this means its performance degrades quadratically as the size of the input increases. It is as similar as the selection sort. It is not the most efficient sorting algorithm, especially for the large data sets, but it is simple to understand or implement. So the conclusion of this video is brute force approaches to sorting provides a simple and intuitive solution, but they often lack efficiency, especially for the large data sets. While they can be useful for small scale tasks or education purpose, they are not practical for the real world applications that demand speed and scalability. Therefore, while a brute force method have their place in their understanding sorting algorithms, and more sophisticated and optimized techniques are necessary for practical implementation. So that was about this video. Thank you for watching.